Now let's talk about parallel circuits. For all of my examples, I'm just going to use two resistors in parallel, but the same is true if I have three or more. For a parallel circuit, you have a voltage source, V, and then you have, well, this is a case of a simple circuit with one resistor, R1, but then you have other resistors, which are in parallel. They'll literally be side by side. You know that the voltage across R1 is equal to the voltage across R2, and it's equal to your battery voltage. So for parallel, you know the voltage across 1 is equal to the voltage across 2, which is just the voltage. So the first thing I can ask you to do is do a diagram. The second thing I can do is ask you for the voltage across any one resistor. So any branch here is going to have the same potential difference. The currents are not the same though. You're going to have some current from the battery. All right, and I usually just call that I. And then there will be a current through the first branch and a current through the second branch. Okay, so you can have some main current coming out, and then let me change colors here. You can have some current going down the first one, some current going down the second one. And you know that I1 plus I2 has got to equal your battery current. So I can ask you for any of the currents, and you can always do a check to make sure you get this correct. The first thing you need to do is find the equivalent resistance. So the equivalent resistance when they're in parallel is 1 over R equivalent is 1 over R1 plus 1 over R2. Now you have to be careful here because you're going to want to stop when you get 1 over R equivalent. You have to remember to flip it. I don't care if you do this in your calculator and invert it to just give me R equivalent, or if you get least common denominators. Let me show you how to get least common denominators. The least common denominator for this is R1 times R2. So you need to come back up here. In order to get R1, R2 here, you need to multiply by R2 over R2. For here, you need to multiply by R1 over R1. So when you add these across the numerator, you get R2 plus R1 is equal to 1 over R equivalent. Again, number one mistake students make is they leave it like this. Flip it. R equivalent is R1, R2 divided by R1 plus R2. Now, once you have the equivalent voltage, the equivalent resistance, you can go and find the total current. So the battery voltage is going to equal the total current times R equivalent. So now you can find the current coming from the battery, which is going to be equal to the voltage divided by R equivalent. Now, how do you find the current through any one of these branches? Well, it's kind of straightforward. V is IR. So the battery voltage is going to equal the current through the first one times the resistance through the first one. So the current through the first one is going to be the battery voltage divided by R1. Similarly, the current through the second one will be the battery voltage divided by R2. Just remember to check and make sure when you do this, all of your currents wind up adding to your add up to your battery voltage. All right, let's try a problem. Suppose I have three resistors of 60, 30, and 20 in parallel across a 90 voltage potential difference. Find the equivalent resistance. All right, let's do the diagram. Oh, not being very nice here. R1, R2, R3, and here's my battery voltage. All right, R1 is 60 ohms. I have no idea what's wrong with my pen right now. R2 is 30 ohms, and R3 is 20 ohms. You can label these. It doesn't matter which one is which for this. All right, so I know 1 over R equivalent is 1 over R1 plus 1 over R2 plus 1 over R3. Now I'm going to do it as simply as I can. This is 1 over 60 plus 1 over 30 plus 1 over 20. You can do it in your calculator, but I think there's a good bit of value in doing it longhand. The least common denominator here is 60. All right? So I don't have to do anything to 1 over 60 to get it to be 60. 1 over 30, to get it to be 60, I need to multiply by 2. 1 over 20, to get it to be 60, I need to multiply by 3 over 3. So this becomes 1 plus 2 plus 3 divided by 60. Or it becomes 6 divided by 60, or 1 over 10. Now it's very straightforward to see if 1 over R equivalent is 1 over 10, that R equivalent is equal to 10 ohms. You never know when you're going to be stuck without your calculator, so be able to do the basic mathematics. Find the current in the entire circuit. Okay, so the current in the entire circuit is, this is your diagram, V and R equivalent. So I know V is equal to I, R equivalent. So the current is going to be the battery voltage divided by R equivalent. And the battery voltage is 90 volts divided by R equivalent, which was 10. So this is just 9 amps. I didn't put what the voltage was up here, did I? Don't forget to do that, because you know how I am. I'll count off. Now, find the current through each branch. I don't really have the diagram anymore, but I'm going to redraw it, and hopefully my pen is doing a little better now. Spoke too soon. So if the voltage across each is 90 volts, and then R1 is 60 ohms, R2 is 30 ohms. You don't have to rewrite your givens. I'm just doing this on a different page. So you can just look back at your old ones. I know V is IR. So the voltage across each one is going to be, say, I1, R1. So the current through the first resistor is going to be V divided by R1. So it's going to be 90 divided by 60, let's go away, which is 1.5 amps. Let me switch colors here. So V is I2, R2. So I2 is V divided by R2, which is 90 volts, divided by R2, which is 30. Let's cancel that. That is 3 amps. Let's switch colors again. So V is I3, R3. So I3 is V divided by R3, which is 90 volts, divided by R3, which is 20 ohms. So that is 4.5 amps. Now, in red, I'm going to do the check. All right? It's always okay to do the check. You'll never get in trouble for that. For the check, I'm going to add up the currents. I1 plus I2 plus I3 is 1.5 plus 3 plus 4.5. So that's 4.5, 5, 6, 7, 8, 9. So this is 9 amps. And lo and behold, that is what the current was in the total circuit. So I'm pretty confident when I'm done with my test and I've done the check that I've got it right. You should walk out of this test with utmost confidence.